Okay, composition of functions. Again, this falls in line with the rest of kind of mathematics as witchcraft. You have to see, how to decode the symbols of functions. And a composition of function is basically going to be taking one function and embedding it into another to produce a third function. This happens quite often when you're dealing with many things. Here out in western Nebraska, we deal with water and volume a lot, and so you might have one function that deals with the speed of a pivot or the gallons per minute we're outputting in a pivot, the mathematics there, and our input is time, and then we want to apply that to another function that calculates the volume of water that's being applied to an entire field. So you're taking time, plugging it into one function, plugging that information into another function, and ending up with the third thing we need. And so that's just kind of I'll quit talking. So let's say we had two functions. F at x equals, we'll come up with something fairly easy. 2x minus 4. And let's say we had another function, g at x equals 3x minus 8. I don't know. Just whatever. And composition of functions works this way. There's two ways you can represent it. So, excuse me, and that's not one of them. Let me gather my thoughts here. So, F composed G at X. It looks kind of like fog, but that's not. This little symbol is the composition function symbol. It does not mean multiplication or division. It's composition. And so another way textbooks write it is something like this: F at G at X. And they're kind of read the same way, F at G at X. And what that means is to take G at X first and plug it into F. So it would look something like this. You start on the inside, and we know G at X is 3x minus 8. And then we're going to plug that into F, which we know F is 2x minus 4. Let me put that down here so we can see it. And so we're going to take that 3x minus 8 and plug it in for x in the f function. So you would have, whoops, not an f anymore. You would have 2 times 3x minus 8 minus 4. And so you plug that in. Whoops. Let me extend the page here a little bit and simplify it. So that'd be 6x minus 16 minus 4. So your new composed function would be 6x minus 20. And so that is the composition of f at g at x. Okay. And so that's one example that we could do with this. Okay. The next thing is let's do the same with some numbers. So and it doesn't matter. Since I switched pages, I'll come up with a new function, 2x plus 1, and g at x equals x minus 4. And so let's say I wanted to compose g at f at x, which in this case would be g, and then instead of x, let's use a number. Let's say we want the number 2. So we want g composed at f at 2. So g f at 2 is another way to write it. And what this says, you start on the inside and find f at 2. Well, we know f at 2 is 2x plus 1, so 2 times 2 plus 1. And so that simplifies to g at 5. Then take the 5 and plug it into the g function. So you go back, there's g is x minus 4, so that would be 5 minus 4, and that's 1. And so that's basically how you do it. Now we could keep going with this, and let's say we wanted, I'm going to try and squeeze it in here on this right side. So let's say we had we wanted g at 3. All right. Well, what you do is you start on the inside and you put g 3 into g, and so that would be g at 3 minus 4, which that's negative 1. And then you plug it into g again. So then you'd have g at negative 1 minus 4. And so that equals, excuse me, you wouldn't have a g anymore. Jeez, messed up again. Sorry. You'd have negative 1 minus 4. And that is negative 5. And so there's composing the same function twice. And it doesn't matter how you do it. You just have to have the inside first. So let's say you had two functions. We'll call them h at x equals x minus 12 and k at x equals 2x minus 3. Yeah, I use that one a lot. And we want to find k composed with h at negative 1, and hope to goodness I don't make a mistake. So h at negative 1 would be negative 1 minus 12. You do the inside stuff first. And excuse me, let me write it so that I get both forms in here. It can be rewritten as k at h at negative 1. And so you start on the inside, so you'd have k at h at negative 1 is negative 1 minus 12. And then you take that, so that would be k at negative 13. And so now you take the negative 13 and plug it in for k. And k is 2x minus 3, so you'd have 2 times negative 13 minus 3. Oh, good Lord. I put the negative in the wrong spot, minus 3, or the parentheses in the wrong spot. And so you get negative 26 minus 3, and that would be negative 29. So all of that composes to negative 29, unless I made an error. If I did, make sure you comment. I'm sure somebody will. Tell me what a fool I am. But good luck with these. I hope that helps and kind of decode some of what's happening with composition of functions. I probably better quit videotaping today because I'm getting tired, making a lot of stupid errors. So good luck. See you next time. Later.